What if you built a product that dramatically improved how hundreds of free open source Python libraries work together and gave it away to the world for free? And then built a thriving business on top of that. It's the open source dream, really, isn't it? This week, we talk with Travis Oliphant from Continuum, who did exactly that. This is Talk Python to Me, show number 34, recorded October 26th, 2015.
I'm a developer in many senses of the word, cause I make these applications, but I also use these verbs to make this music. I construct it line by line, just like when I'm coding another software design. In both cases, it's about design patterns. Anyone can get the job done, it's the execution that matters. I have many interests, sometimes conflict.
Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm and follow the show on Twitter via @talkpython. This episode is brought to you by Hired and Digitalocean. Thank them for supporting the show via Twitter where they're at Hired_HQ and at Digitalocean. That's right, Digitalocean has joined Talk Python to Me as a sponsor. Thank you guys for supporting the show. You rock. Hi everyone. Thanks for listening today. Let me introduce Travis so we can get right to the interview. Travis Oliphant has a PhD from the Mayo Clinic and a BS and master's degree in mathematics and electrical engineering from Brigham Young University. Since 1997, he's worked extensively with Python for numeric and scientific programming, most notably as the primary developer of the Numpy package and as a founding contributor to the SciPy package. He is also the author of the Definitive Guide to Numpy. As the CEO of Continuum Analytics, Travis engages customers in all industries, develops business strategy, and helps guide technical direction for the company. He actively contributes to software development and engages with the wider open source community in the Python ecosystem. He has served as a director for the Python Software Foundation and as a director for NumFocus. Travis, welcome to the show.
Hey, thanks. Appreciate it, Michael.
Yeah, I'm really glad to have you here on the show. I know you guys are doing some amazing stuff with Python and really leading the way with the whole scientific computing angle of it. So I'm really excited to talk to you about that today. But before we get into absolutely. Before we get into the details, though, what's your story? How did you get started in programming?
Well, programming was a young child. I was fourth grade, I believe. I remember my first Atari basic class. It was an after-school program. And I just got pretty excited about it. My dad was a programmer as well, and so part of it was, I can kind of do what he's doing. But the computers back then were very accessible to a hobbyist mind, and the expectations were low too. We didn't have, interactive video games to try to reach. It was an interactive text game was actually interesting, and so I just got started there and had a Timex Sinclair, a TI-49A. Hobbyist computers, and I was kind of doing it from the very beginning, and I enjoyed that as well as I enjoyed a lot of math. So my first, I wrote Pascal in high school as part of an AP computer science class, and then went to college and where I was studying engineering and physics, and I learned C, and that's kind of how and then I started using, learn MATLAB and a bunch of stuff up there.
Okay, interesting. So you kind of built up into the more serious languages like C and so on, and then I'm guessing you're doing MATLAB because you were trying to do some kind of scientific visualization stuff, right?
Yeah. It's a high-level array programming for electrical and computer engineering, controls and signal processing, image processing. It was much easier. It was much easier to think at a high level than have to worry about all the details of programming. I could program in C at that point, but it was much nicer to think at a high level and not have to worry about those details while I was thinking about the math problem I was solving. Yeah,
that's for sure. No matter how good you are at C, you're not going to be that efficient in it, right? You're really, really way down there, right? And so MATLAB is really great for building these simulations and answering these questions. But one of the areas where those types of systems fall down is like building actual apps that run, right? That you can run in production. And so is that kind of what led you towards the Python story?
Yeah, a little before that, because I was still a grad student when I found Python. It was two things. One is in the back of my mind, I was bothered that I was sort of writing in MATLAB, and anybody who wanted to use my code had to also have this, buy this expensive package before they could benefit from what I'd done. And so that always sort of bothered me. And then I didn't. Then what was the proximal reason I had to switch to Python was I ran out of memory. I was doing very large 3-dimensional simulations of 5-dimensional data, but it's 3 dimensions of space and time and a third axis of polarization. And it just wasn't fitting in memory. So if I switched to float 32, it would fit for the kinds of problems I was solving. And they didn't have those data types in MATLAB, so I was looking around for another way to do this. And that's when I found Python and the numeric package and kind of got hooked. I had done some Perl scripting in the past to kind of steer scientific compute, like Fortran libraries. And so I understood that use case, but I also, having the numeric package available, let me do high-level simulations quickly. And then just this wealth of other things got me kind of started. And I just loved the language and the syntax, and it was close enough. I didn't have to think about computer science. I could think about my problem at a higher level. So that's what hooked me. And then it was readable later. That's what I really appreciated about it. So that was in grad school about 17 years ago now, that I got started with Python.
Okay, that's cool. Yeah, you and I were in grad school, not too far apart, actually.
Oh, cool.
In time, maybe in distance, but in time. So the scientific Python looked really different 15 years ago than it does today. I would say scientific Python looks really different 2 years ago than it does today, but that far back is really interesting. So maybe you could tell us what it was like then and how you've seen it evolve over time.
Yeah, so back then a lot of scientific Python was steering other codes. It was a lot about, you'd write a script to kind of call other either machine codes, other codes written in C or Fortran, and you'd be steering, and you're doing a lot of data munging, maybe file reading input data and writing it out, kind of using the string processing facilities. And then because Python could be extended, then it was not too difficult. The Swig package was available at the time, and it was really instrumental early on in kind of making it easy to wrap large code bases and make them accessible to Python. And so people were able to then kind of have objects in Python that mirrored their low-level objects. And so they could start steering their program from a high level. And that kind of, as numeric, as an array processing library emerged, and then NumPy came a little bit later, after NumArray, it's kind of that whole process led to more people actually at a high level just building their array-oriented constructs just in Python itself from the very beginning, instead of having it kind of be an object layer on top of low-level machine codes.
Okay, so in the beginning, it was just about sort of an easier API to what people were already doing in other places.
Yeah.
But then,
and helping to test those too. It kind of became like it was really easy to test your C libraries, your Fortran libraries.
Right, absolutely. But then it sort of, the more it caught on, it was more like, well, we'll just stay here, right?
Yes, right. I can just use this. Like the spelling here is nicer and easier, and I don't ever have to drop to the C level. And there were some real important things that happened that conveyed that. Now, that process is still happening. I mean, there are still people that write Fortran, still people that write C. And the fact that Python is this great glue continues to make it a strong use case.
You were one of the people that was involved with NumPy and SciPy and all that, actually getting that off the ground, right?
Yeah. I was the grad student who was really, like I said, I fell in love with Python as a grad student. And it was a weird reaction to have for a language, but what I loved is just the ability to do things quickly. I could sort of iterate quickly. I could think at a high level. The concept of Python fits your brain and gets out of your way is a common meme. I just totally felt that. I could think about my problem. And then, so I got excited about it. And then I looked around and said, well, but I'm missing some libraries here. I need integration. I need optimization. I need statistics. I need these linear algebra libraries. And a few of them were numeric, and there were a few scattered around. But I kind of got bee in my bonnet around 1998, 99, and started I learned how to write an extension module. Guido and something called Table.io from Mike Miller showed me how to write an extension module, and then I just got hooked, and I started writing a bunch of them.
That's great.
So around a whole bunch of old Fortran codes, kind of made them more accessible, and that's kind of the beginnings of the SciPy project.
Yeah, very cool. Take that C knowledge you had and put it to use there, right?
That's right. And this was back when you had to hand wrap and track reference counting, and it was the fact that I knew C was really critical to making sure that would happen. It's certainly a lot easier now. You can do it with Python. Numba. It's really easy now, actually.
Yeah.
Comparatively.
These kids, they don't know how good they have it.
Right.
So somewhere along the way, you started a company called Continuum, yeah?
Yeah, that's fairly recent, actually, in the whole history of things, since I've been doing this for 16 years. And, I was a professor for a while, and that's where I wrote Numpy, kind of growing from the work of the Space Science Institute, the NumArray work, and then, the previous work of numeric community. Numpy brought it together in 2006, 2007, and that's been very successful. It's really thrilling to see how many projects have been building around that, and then also it's been thrilling to see the community rally around and keep supporting Numpy. There's a lot of great people contributing to that project today, and same is true of SciPy. But I left my academic career behind around 2007, and I had 6 kids. I need to support them, so I need to figure out a way to make my way in the world, and started doing consulting around Python for Enthought in 2007, and then in 2011, Peter and I were kind of talking about some gaps, and really trying to realizing that Python needed to make a bigger story in the big data world, and have a stronger play in the web visualization and big data world. And so we started a company in 2012 to really make that happen. Yeah,
and your company's called Continuum, and you guys have a really ambitious goal, a really lofty goal. And I love reading your website because, it's kind of like there's all these great scientific projects and thinkers and stuff out there, but when they go to solve their problem, they end up, stuck at a command line saying cannot compile some random C thing because they're trying to install, a Python module that's got C extensions, and they just, they're stuck, right? And so if you could build an environment where everything was sort of import anti-gravity, right? It's like all super easy, but even for the science-y stuff that's hard, right? That's kind of your goal?
Right. That's definitely a part of our goal. I would say that at Continuum we've had no shortage of lofty goals. We Peter and I are both ambitious thinkers, and have kind of full of ideas and thoughts. And I've had things been building up over years. So when we started Continuum, we had really, really ambitious goals, not only around package management. Really, that kind of came as a corollary of our other goals. Our goals were to make it really easy for data analysis and scientists, people that change the world is the way we talk about them today. People that change the world need a way to do it easily and not to be loaded down by DevOps and issues. And they need to be able to create visualizations that show up on the web, and they need to be able to take advantage of modern hardware easily. So they need to run in parallel, they need to be able to take advantage of GPUs, and they need to be able to translate their great ideas into code that does that with a nice web front end. Right. So, and then if we're going to really pull that off, we've actually got the first problem is how do I ship this great stack of tools to people that I built? And so Anaconda came as this really immediate corollary from our overall goals. We needed to really work on the packaging problem.
Right. So you're thinking data science, visualization, scientific computing. Okay, Python.
Right.
Now,
data science at scale in a web browser visualization. How do I get that installed to everybody? And we got to work on the distribution problem.
Right.
The starting point.
Yeah. So vanilla Python's a fine base for that. But if you've tried to install, matplotlib on Windows.
Yeah, exactly.
It is no treat, right? You're like, what?
No treat, right.
What is up with this vcvars.bat? I didn't want this.
Well, what's cool about Python is how easy it is to integrate with so much other stuff, right? It's a glue that really, it's why it was adopted in the scientific domains and why it continues to be powerful. But the other end of the stick of that glue means you've got a lot of other systems you're interacting with. And so installing something, SciPy, for example, has notoriously been difficult to install because it relies on Fortran code. So you're compiling Fortran code, and then you're integrating it. And, I use Fortran. I mean, any decent scientist can use Fortran. Well, today people are like, I don't want to have a Fortran compiler managed on my system. So it becomes a challenge. And then, the visualization compounds that with additional C libraries and additional configuration issues that are slightly different on different platforms. And just how do you bring all that together? It's a hard problem. And so we've taken strides, and part of that part of those strides is creating the Conda package manager. Really having a cross-platform package management solution that goes beyond just Python and lets you install Node and R and anything else, Java, Ruby, Scala. You can install all of it with Conda. And then on top of that, being a definitive source for freely available binaries on multiple platforms for these primary fundamental packages that make up the PyData stack.
Okay, so that's interesting, both of them. But the fact that you say, all right, well, how different is everybody's Mac? We could probably compile that once, and then nobody has a problem of getting this obscure compiler to work on their environment, right?
Right. That's an important question, actually, because what is a platform? We've asked this. We have to look at this question really hard. I mean, a platform fundamentally is actually the tree below you. It's all the software dependencies that you're not caring about, that you depend on. That's actually a platform, right?
That's right.
Now, when we talk about OS platforms, people kind of cut that tree at a particular plane and usually go, well, okay, we're going to use the OS for lib C and this set of libraries, and everything else above that is managed from the package manager. And for us, the way we manage that is like a Windows. They do a lot of work to manage that. And basically, if you compile for a particular Windows box, it's going to be pretty well assured to work on every release of the software above that. So usually it's about picking the baseline. It's about picking the baseline. So with Windows, we used to be Windows XP. I think we just moved to Windows 7. That's kind of our. That's where we compile all the software so that it works on Windows across that. Which compiler do we pick? Well, in Python 3.5, they just moved to Visual Studio 2015. In Python 2.7, it was Visual Studio 2008. And so we manage that. And then on Mac OS 10, okay, it's version 10.7 of the OS. That's where in this version of Xcode, that's our base. On Linux, it becomes a little bit harder, but there it's the compiler and the libc, and then everything. It doesn't matter which distribution it is; it works on your. The only we rely on is the libc.
Okay,
so
yeah,
that's how we manage it. Right? But these are hard questions.
Yeah, and it's hard to generalize that, but I think that's a really hugely valuable service because, I think it was this morning I was trying to install MicroWSGI on Ubuntu 15.10, and for some reason it would not compile correctly trying to install the main environment, but it would go into the virtual environment, right? And just these little headaches you keep bumping into, and when you're experienced, you're like, okay, fine, we'll just do it this way or that way. But when you're new or programming is not your full-time thing, you're a scientist,
right?
And you just need to do
it's a showstopper.
It's a showstopper, right?
That's exactly right. Now, and that's actually something, a lot of people have, because Conda has emerged at the same time that the Python packaging has been improving. Pip and virtualenv have gotten a lot better over the past several years than they were when we started. And our story in Conda has some overlap with that, but it really has a different focus. If you use pip and virtualenv, you're saying, yes, I'm an integrator. I'm going to make this all work for my system. And that's great. I mean, that's something people want to do, but not everybody wants to do that, or really should be trying to do that. Conda is about, and Anaconda is about, here's an easy-to-use platform for open source analytics that you can just get started with out of the gate. You don't have to be worrying about configurations right before you get started. Just get started, right? And then you can decide later how you want to potentially, build your perfect system. And whether you continue to use Anaconda or binaries, or you decide you're going to use Conda but use your own binaries, that's a decision you can make down the road. Or maybe you just want to recompile all, to get the stack you want and recompile everything the way you want it. All that's still available to you. We're just trying to get you started quickly and get you using this great stack of tools.
Yeah, that makes a lot of sense, because once you've got a working system, well, then you're willing to put in that 4 hours to get that thing set up. But
right.
If you're trying to decide if it's even suitable for experimenting with, you don't want to spend that 4 hours,
exactly.
Right?
Exactly. And that was our goal from the very beginning. I'm really excited that I personally think we've helped with the recent explosion of Python in the PyData world. Just how many more people, it was said that actually Python is the fastest growing data analytics language. Its rate of adoption has overtaken R. Python and R, for a long time, Python was overshadowed by R. Like, nobody really talked about Python as an open source language. It was always R this, R that. And R's great, Don't get me wrong, it's got some great things about it. But Python is used in a lot of the same contexts, and it's only been fairly recently people have looked around on a commercial side. Companies looked around and said, wait a minute, database vendors, for example, and said, we got to have Python support too, not just our support.
Yeah,
so that's been really great to see.
That is really great to see, and I think you're right about you guys helping with the explosion there. I mean, to me, it's NumPy, SciPy, and then it's IPython, and maybe a few other things. Or
Pandas has made a real big difference over the past several years. A lot of people using Pandas now for data analytics. For data frame kind of operations.
Yeah, and a lot of those are not easy to set up and install and get going with. And so having this distribution is really great. So maybe we could, you talked about a couple of things. You talked about Conda and you've talked about Anaconda. This episode is brought to you by Hired. Hired is a two-sided, curated marketplace that connects the world's knowledge workers to the best opportunities. Each offer you receive has salary and equity presented right up front, and you can view the offers to accept or reject them before you even talk to the company. Typically, candidates receive 5 or more offers in just the first week, and there are no obligations, ever. Sounds pretty awesome, doesn't it? Well, did I mention there's a signing bonus? Everyone who accepts a job from Hired gets a $2,000 signing bonus. And as Talk Python listeners, it gets way sweeter. Use the link hired.com/talkpythontome, and Hired will double the signing bonus to $4,000. Opportunities knocking. Visit hired.com/talkpythontome and answer the call. Let's maybe focus on Anaconda for a minute. So you've got sort of 4 interesting, I don't know what you call them, maybe pillars or concepts behind this distribution. And I thought they were pretty cool. So I'll sort of go and maybe we could talk about them a bit. So one is you're committed to open source now and forever. What's the story there?
Yeah, so one of the things we want to make sure people realize is our roots are in open source, right? I mean, I spent years building SciPy and years building NumPy. And when we started the company, we wrote Bokeh and Numba and Conda, and they're all open source. I believe infrastructure should be open source. And one of the goals I had in starting Continuum was to create an organization that would allow a sustainable production of open source by also selling things for enterprises that drives any revenue produced by selling solutions to enterprises can actually support growing more open source software. I really believe it helps everybody, and it helps places you're not even able to target and help. So we're real believers in open source. We believe in it. We think it's important. We also believe in building on top of it and having things we sell on top of it. But we want to give back to the community at every opportunity we have and can. So Anaconda, as a distribution of the open source ecosystem, is our perspective. It needs to be open source and will stay open source.
It's really interesting to me how successful people have been with open source on the large scale and on the small scale lately. And I think this is a new trend. I mean, you probably know better than I do, but I'm thinking of companies like MongoDB that are,
Yes, Pengen, MongoDB, that's right.
Yeah, over $1 billion valuation. And you can go to GitHub and get their thing they're selling for free. I mean, it's so paradoxical, but it's really interesting.
Well, some of that still has to be played out, I think, in the marketplace. I mean, some of these large-scale evaluations are a bit mark to vision, mark to dream.
Yeah, they're looking ahead. We'll see.
They're not quite proven out whether or not there can be, is there going to be a sustainable, repeatable a cell cycle that's going to drive that. There are known, but I think the reality is there are known sales conversations that can drive open source, and those have been identified, and I think there are more to come. And people are recognizing that in order to play in the ecosystem of tomorrow, you're going to have to be open source because the developers are going to demand it. The people you have huge advantages in terms of what people know already. So if you don't, you're going to have to train people a lot more than you do if you kind of go with what open source is driving. I think there's a lot of factors that drive it, but we're basically a group of folks that we drank the Kool-Aid long ago, so we're just continuing that. It's sort of part of our core. It's not something we just sort of, hey, let's try this, jump on this bandwagon. It's who we are.
Yeah, you guys have been there from the beginning. That's awesome. But yeah, I definitely think that not only is it becoming, so there's lots of examples of businesses doing it successfully, but like you said, it's being accepted by purchasers, people who are going to say, I'm going to buy a service. Well, of course, I'm going to go get this open source project and I'll get the commercial support or whatever. Whereas it used to be kind of this edge thing, like, well, maybe you can save some money, but you might pay for it later when it doesn't work quite right. It is that discussion is sort of sailed, right?
Yeah. I think there's still some questions around. I mean, I personally believe there are a lot of people benefiting greatly from the Python and the PyData stack that need to figure out how they're going to help support sustaining it. Either there's got to be, you buy a commercial distribution, support NumFocus. I mean, there's got to be some dialogue around how are we actually going to make this work long term. So I would definitely love to encourage people to take a hard look at if they're relying on this for their day-to-day, think about how that's going to maintain.
Right. Don't shoot yourself in the foot, right?
Right. Don't let today's price point be the enemy of tomorrow's success.
Yeah, for sure. So that was sort of pillar one. Number two was tested and certified packages to cover your back. Yep,
that's right. So that kind of speaks to we do a lot of work to make sure the Python works together. And so we have a process where we release we have a download and we have a repository. When we make a release of Anaconda, we basically are saying this group of software works together, and we've done some integration testing. When we make a release of a package into the open source repository, we've done the testing on this package that works and a little bit of integration testing, but we haven't done like full integration testing. So you kind of, depending on where you want to sit, do you want to sit and take only Anaconda released versions because you want to make sure it all works together, or maybe you're willing to deal with the occasional, hey, this new release of software X doesn't quite work with this other piece. It's easy to fix, but you might have to get the configuration that works just right. But either way, we've done testing at various levels, and we basically promise it'll work. We as a commercial thing, we do offer indemnification as well. So that's one of the features we provide to people that buy a subscription is we will actually indemnify you against the concerns about open source using and deploying open source in your organization. We'll make sure that you're protected from copyright infringements and patent infringement concerns that the company may have.
That's a big deal. That's really cool.
Yeah.
So with the sort of consistent packages, how many different packages are in the Anaconda distribution?
So the Anaconda download, we've actually been paring it down, trying to make that download manageable 700K or 700 megabytes instead of, it could grow to be 3-4 gigabytes. But we've been paring it down. I think it has about 70 to 75 packages that are in the downloadable. And then in the repository, that's a quick Conda install away, is 330 currently.
Okay.
And growing. And then, of course, you have access to everything else through pip, or you have Anaconda Cloud, which provides additional sort of community provided. Anybody can make a Conda package and put it in Anaconda Cloud, and then they can go and you can install it from there too.
Okay, excellent. Yeah, one of the challenges with sort of this mix and match open source feel is there's nobody's job or responsibility to make sure that all of these pieces fit together, right? There's a whole host of developers, more than 70, working on those 70 packages.
That's right.
How much coordination are they doing, right? I mean... None.
Well, a little bit.
Yeah, I'm sure a little bit.
They each have their own... They each use some corner of the stack, right? And so they'll... For their itch, for the things they care about, they make sure that works together.
But it can definitely fall apart. Like, I've periodically decided, I want the new stuff. And so I went to I just did a pip upgrade, everything in my installation.
Yeah, that's right.
That usually is okay, except for, a few where it's not anymore, right? So
right. And if you're willing to deal with that, and some are, and it's kind of fun sometimes, right? To be on cutting edge, it works okay. And it just sort of depends on which cut you're making through that stack.
That's right.
But especially when it comes down to, hey, I've got, I'm tied to this vendor-specific library, this BLOS or LAPACK linear algebra library, or I've got this, visualization stack that requires this version of that GPU driver. I mean, it's really hard to get that working together without somebody doing that testing.
Yeah, I can imagine. So you guys got that covered. That's cool. So the third one is explore and visualize complex data easily.
Yeah. So here we're basically advertising the capability of this PyData stack, helping people understand what you can do with it. And, the fact that you've got such great visualization tools, we spend a lot of time on Bokeh, but we also use Matplotlib, and we use, the BizPy and Mayavi and the other tools that let you basically bring your data to life quickly and inside of Jupyter or on the command line or inside of Spider, depending on exactly what you want to use. All of it's available and easy and kind of at your fingertips.
Yeah, that's excellent. I installed Anaconda and go into the environment, IPython space notebook, boom, everything works. It's ready to roll. It's nothing to configure, right? Same thing for Spider. You can pull up the IDE, which is like a scientific computing IDE type thing, and it's all right there, right? So that's cool.
Right. So that's basically, the plot works, and for Matplotlib, and then if you're Bokeh provides a charting API, so you can do complex histograms. The Seaborn interface to Matplotlib works out of the gate. Pandas has its histograms and plot tools. You can just bring up a data frame and type .plot on it, and it'll bring up this interesting plot. Just lots of things available. You just basically have to do a Google search on the kinds of analysis you want to do, and it's all ready to go. Yeah. And almost all of it will work out of the box.
Yeah, that's really cool. I definitely, if somebody out there is learning data science, definitely start with Anaconda, right? Because then you got to focus on the actual thing you're learning and not fighting with compilers.
Exactly. Not becoming a distribution, not becoming a self-integrator. It's the official term that Nick Coughlin uses for people who are using pip.
That's great. So you talk about Bokeh a lot, and I don't really know much about it. What is it?
Yeah, great. So Bokeh is, I say Bokeh, but people can say Bokeh. I think Bokeh is, it's a plotting library for people that don't want to have to learn JavaScript, but want visualizations in the web.
Okay.
So it's kind of like D3 for the rest of us, kind of for the data scientist who knows Python or R or another high-level language, but you can write complex visualizations, kind of high-level plotting, charting, histograms, cross-plots, but have it show up in the web. So that's Bokeh. Bokeh has a JavaScript side. There's a JavaScript. Actually, I think CoffeeScript is the current implementation detail, but it's a JavaScript library that you then embeds in your browser, and you communicate with it via a protocol. So JSON objects, and we communicate it back and forth between your server, either as a one-time static publish. Embedded in my HTML is this JavaScript that talks to the Bokeh.js and produces this visualization. So you have a static interactive plot where interactive, I mean, you can zoom into the data, you can drag and drop, you can, slide, you can do selections of points and have the visualization update as you're doing that selection.
So the data is static and it comes down all at once, but then you can explore it however you want, sort of visually.
So that's one use case, right, where you want the data static and you want it all in your browser at one time and you're exploring it all at the same time. But the other use case, it's an important and growing use case, is where you have too much data. You don't want it all in your browser. You have to interact with a large data set, and you're communicating via maybe a WebSocket API or a kind of an interactive API. The browser is talking to a client, and you're interacting, sending viewport information back to the server, and there's a Bokeh server that's then bringing the information and changing what's actually shown up in the browser directly. So there's this bidirectional communication happening between the server and the client, and that also works, and and it's just pretty straightforward. You don't have to know all those details. You just kind of set up your visualization in a very simple API, and then that kind of comes for free. That interaction kind of comes for free. And there's a lot. So there's a lot of possibility there. And so there's an API. There's a plot. There's a lot of great APIs. There's a plotting API, kind of relatively low level. It's not really that low level. It's kind of like the plot level with I'm going to change this glyph, I'm going to change that glyph, put these axes here. Then there's a charting API that might take a data frame, might take a high-level object that you can then quickly build a histogram or a nice chart. Then the other thing Bokeh provides is novel graphics. Like you can I'm going to draw a glyph, I'm going to draw rectangles, I'm going to draw circles. and kind of and because we come from the scientific Python background, it's vectorized interface. So with a single segment command, I can draw 100 lines, and I give all of those endpoints in one big vector. Does that make sense? I can kind of have a single command will generate a bunch of circles.
Yeah, sure.
Or a bunch of glyphs.
Yeah, I was looking at some of the graphics on bokeh.pydata.org. And
yeah, exactly. It's a great place to go.
Yeah, there's amazing stuff over there. Yeah, it's just like a contour plot, all the different kinds of plots you can think of, and just that's really nice.
Exactly. There's some examples of chloropleths and kind of novel graphics is one of the key pieces. So the key things are novel graphics. It's a library. It's a fast library. Kind of if you have visualization you want to do and you have data you know how to access in Python. Or R, actually. There's an R bokeh interface. Check out bokeh because it may help you get your visualization done quickly. And it can produce a static HTML or it can produce an application, basically a visualization application.
Yeah, that's really cool.
With a server-side component.
Yeah, and because it runs on JavaScript, sort of you automatically get like distributed computing, right? You offload a lot of the computation to the viewers, right?
Exactly.
This episode is brought to you by Digitalocean. Digitalocean offers simple cloud infrastructure built for developers. Over 500,000 developers deployed to Digitalocean because it's easy to get started, flexible for scale, and just plain awesome. In fact, Digitalocean provides key infrastructure for delivering Talk Python episodes every day. When you, or your podcast client, download an episode, it comes straight out of a custom Flask app built on Digitalocean, and it's been bulletproof. On release days, the measured bandwidth on my single $10 a month server jumps to over 900 megabit per second for sustained periods, and there's no trouble. That's because they provide great servers on great hardware at a great price. Head on over to digitalocean.com today and use the promo code TALKPython, all caps, no spaces, to get started with a $10 credit. Yeah, if you're trying to generate JPEGs and send them down, it's all on your server.
Yeah, exactly. It's kind of in the direction of modern web applications. It's always been possible to publish, images and static plots to the web. That's sort of just traditional standard HTML serving. You embed JavaScript, now there's a bit of interactivity. And the next step, of course, is to have that bidirectional communication with the server. That they use WebSockets to do that, and bokeh makes it easy to take advantage of all of that.
Yeah, and it's already beautiful, so you don't have to be a designer. Very nice.
Right, you don't have to be a designer. Right, you don't have to learn JavaScript. We wrote the JavaScript, so you don't have to. It's one of the kind of make it accessible to the data scientist or the scientist who's the issue with this. The data scientist they may learn Python because it's accessible, not necessarily become an expert Python programmer, but they're going to learn enough Python to do their workflow and to accomplish their goals. And they don't want to learn a ton of languages in order to get all the way there. And quite often getting farther along means building a publication or building a graph, building a visualization. And so, our mission is to support that group of people and make it really possible for them to translate their ideas and their thinking to real-world interactive visualizations they can communicate to somebody else about and have that just happen seamlessly and transparently. And we do that, part of it's open source libraries that form a core, part of its integration pieces that we maybe sell at a high level, and some of it's just doing services for somebody to build that solution for them and ship it on premise.
Yeah, really nice. Did you guys create bokeh?
Yes. Bokeh is a project we started.
So did you look around at the other things that were out there and say, you know what, all of these are nice, but they just don't quite fit the story of getting on the web?
We did, yeah. Exactly. We spent a lot of time. We looked at D3 pretty hard. Some people have done a really good job of putting Python interfaces to D3, and certainly bokeh. You can also integrate D3 and bokeh together. They're not sort of. It's both. It's in the web, so you can build kind of mashups. But we wanted to use the canvas. We wanted to make sure we could scale out to millions of points, and we actually can get to billions of points, not in the browserness per se, but you can deal with billions of points and then push the ones in the browser you need. We have a technology called data shading. It's a really exciting technology associated with the Bokeh project that's up and coming. Kind of one of the only ways to visualize billions of points easily. And we wanted to control over that. So we knew kind of where we were headed. We knew we had to do that. And, it's been really good. It's hard because you have to build a JavaScript library and build the Python interface on top and then promote it, ask all the questions. But it's given us the control. One aspect about other JavaScript libraries is they weren't really built with other languages in mind. There's a lot of libraries that say basically, just be a JavaScript developer and then you can use it. If actually Bokeh is a JavaScript library that's easier to use from Python and R than it is JavaScript.
Yeah, that makes a lot of sense. I mean, a lot of those great libraries, they're like, okay, well, you can do this in the client side, and then you connect to your own custom services that you dream up.
Yes.
And you write the server side, and you do all that stuff. And again, if you're a web developer, fine. If you're a data scientist and you're trying to solve a problem, it's easy to forget as developers that not everybody in the world is a developer. They have their own special skill, right? And so let them focus on their skill. That's cool.
Right. And the cool thing about Python, honestly, is it bridges that world, those worlds. And it's because of I think it's because it was a teaching language to start with. And so it's meant to fit in your brain kind of and not take too much space there. And to leverage your English language centers and other things you do. And the white space, the visualization, the white space consistency is part of that. And so it's because of that, lots of capability, lots of scientists, lots of data scientists come to Python and can work there together. And they start to want things like a developer would want, but they want it a little differently. They don't want to become developers. They just want the capability.
That's right.
Kind of presented to them.
It makes perfect sense. Yeah, it makes perfect sense. So what does a typical Anaconda user do? Like, who is your typical user? Like, what are some notable things people have created, things like that?
Oh, yeah. I mean, that's a great question. They span the spectrum. Something I love about the work we do and what I've been doing for the past 15 years, honestly, is just the breadth of smart people that we get to interact with. So it might be a geophysicist trying to understand where to find oil. It might be someone managing a reservoir. It might be somebody on Wall Street. Maybe they're managing a portfolio for their clients, or maybe they're trying to figure out a new derivative, a way to manage risk and trade risk. Or they're trying to figure out how to avoid a 2008 crash, figure out what their risk of exposure is to people. It could be, we have people who are actually is really great user, has a story around they're finding rare diseases. They have a way to use microscopy to kind of single gene changes that cause certain rare diseases. So there are diseases that are not well funded. Nobody looks at they're hard expensive to do anything with, but they have a technique where they can study it and understand it because it can be reproduced with a single gene knockout or a single gene change. And so they're using Anaconda and Bokeh and visualization to try to and Jupyter notebooks to look at workflows where they image a bunch of cells with different knockouts and try to find drug treatments. There's pharmaceutical companies who have lots of drugs that they're looking for use cases, right? And they have a platform for essentially testing these use cases against these single knockout models of genetic diseases. So, people who are helping essentially find cures for rare diseases, basically using these tools, which is awesome to see.
Yeah, that's really great to see people actually making lives better with software that you create or at least help support, right?
Exactly. That really makes my day when it really helps motivate. It helps motivate me. It helps motivate the company. It's what we try to do is really make, it's like our mantra is, we make the world better by helping people that change the world and do their job.
Yeah. Very cool. What is the most surprising sort of use you've seen people try to do something with? That's
interesting. I think some of the embedding, people embedding it in really small footprint places. I think that's what, I didn't expect people to try to get Anaconda running on a tiny phone or tab, or since they're getting bigger these days. But I'm less surprised now, but I think early on I was kind of surprised.
Yeah, what people do with mobile stuff these days is
the Raspberry Pi. The Raspberry Pi was an example, but we had one cute Elon for April Fools a few years ago did a Python 1.0 Conda package. So you could Conda install Python 1.0.
How nice. Funny.
Just a proof of concept.
Of course.
You can manage all kinds of versions of Python. That's a hard one. I'll have to think about that. There's a lot of great use cases, but
yeah, it's hard to pick the most surprising, right? They're all surprising, right. I'm sure. We talked a little bit about running a business on open source. And I went and I got Anaconda and I downloaded it. And you didn't even make me give you my email address, which thank you for that. But you have Anaconda free, and then you have some other things that are kind of products. So you've got like a Pro, a work group, and an enterprise version. And you also talked about the Conda Cloud. Is that right?
Yeah, Anaconda Cloud. Yeah.
Okay. What are all these?
Yeah, so maybe I can address the first question kind of generically. We do have to sell things to be a business, right? Like businesses, at the end of the day, they sell stuff, right? And what we sell is we sell services, we sell training, we sell software. And what we described is our software offerings, and we have subscriptions to Anaconda, and their targets are really the enterprise usage. You know, if somebody, we want hobbyists and academics and even people in enterprises to use this. But if you start to become dependent on it, you're allowed to think about looking at subscriptions so that we can support you in your use cases and make sure that your, new versions don't go awry and you can be well supported. So the first tranche is basically just supported Anaconda. And that gives you the identification and then the priority support so you can call us and kind of get what you need fixed on your time scale instead of ours. Or instead of sort of open source timescales. So that's kind of the first thing. Kind of I personally believe that that's not enough. I think people, from a business perspective, I think just the way we are as people, we kind of we need kind of additional stuff in order to get us to open the checkbook and send out money. We need kind of get more stuff. So so we've added additional things into the work group and enterprise subscriptions, and those are in the direction of, repository management. One of the things Workgroup provides you is the ability to manage exactly what Anaconda users internally are getting. If you download and install Anaconda, you can point to our repositories and get kind of this open source set of repositories. But a lot of companies want more control over that, and so Anaconda Workgroup gives you a chance to have your own private mirrored repository. You can control what goes there, and you can also, you can build packages and upload them to there and manage kind of the deployment of Python and applications built around Python throughout your organization. So it's kind of a repository server. Yeah,
there's certain places where that matters a lot.
Right.
Either it matters a lot or it doesn't matter at all, I think.
Correct. That's exactly right.
So,
exactly right.
Like I did some work.
Exactly right.
I did some work with the guys at NASA, and I was showing them all sorts of, okay, here's what you do, and you got to install this and this and this, and you just, they're like, whoa, wait a minute. We can't just, download that stuff and install it here. Like there's rules and there's restrictions.
There's rules
it's got to be approved and, so
right, exactly.
It's to address that problem, right?
Yeah, exactly. So Anaconda Workgroup becomes a single point of, we know it's approved here, and then we can control it, and it kind of helps the IT organization understand it. And, it's growing things like, so it manages environments and packages and notebooks. You can actually see what's deployed for somebody with Anaconda Workgroup by going to Anaconda Cloud. So Anaconda Cloud it's at anaconda.org. It's a URL, but it's the Anaconda Cloud story is kind of what gets installed behind your firewall if you get Anaconda Workgroup. Anaconda Cloud is really about people who just gives everybody the ability to have, I want to publish my Conda packages and have other people see them. And it gives you an easy way to do that. So you can say, hey, here's my environment. It's got these package dependencies. And I want to be able to point somebody to it so they can get it exactly. Not just they have to rebuild it and then hopefully get the same environment I had, but here's the binary packages that actually work for me.
Yeah.
You can put those in either individually, and also we have an environment specification, an environment concept, and then you can publish that, and somebody can just point there to Anaconda Cloud, and then they can get exactly the reproducible result they're looking for.
It can be a big problem in science. When I was talking to the guys at the LHC, it was a really big deal.
Yes, exactly.
The reproducibility, making sure you have exactly the same version of everything. And if you're working in science, reproducibility is kind of key.
It is key, exactly. Science, but also businesses have the same problem. They want a lot of time is spent just like, oh, I had this bug. Well, okay, in which version of what software and what was your data environment? Like just getting that reproduced so where you can actually figure out what's going on. People spend all kinds of money and time doing that, and this basically we have a part. Our technology helps in that solution to really streamline that story. I would say it's not as well appreciated, I think, as other. We have not had the resources to market quite as big as other people have. We're trying to change that, but the ability to take Conda, people who use it and really find out, oh, Conda environments, this is really nice. I can do this very quickly, because the rest of the IT world is pushing other stories, and some of those stories aren't good. They just sort of overkill sometimes, and oftentimes a simple Conda environment will give you that reproducible environment very easily, very quickly.
Right, like one of the alternatives might be, hey, go use Docker and get this series of images. But
correct.
Maybe
I think people, and that's great. Docker is great, but I think it's overkill for some of these use cases. And this is sort of lightweight.
Again, not everybody's a DevOps engineer.
Correct. Also, exactly. So we're working closely with the Jupyter community and others to try to. I think there's a really it's getting to the point where people can quickly do this, and we're constantly making improvements to the UI and how easy it is to do, and make sure it's make sure that we don't require turn you into another DevOps person. I mean, there's some of that that's maybe a little harder than we would like today, but some of it's really easy, and people are able to do it successfully. So that's kind of Anaconda Cloud, and the work group provides that capability on premise. So you don't you can own it, control it on your servers. You can decide how your people use it. So for testing and reproducibility, there's also a component that we manage a build. There's kind of a build queue so that you can actually submit jobs and get kind of continuous integration of your packages and have things up and running all the time. So that's an aspect of the product too. So things like that we're selling on that side. Then we also for enterprise, that next level is where we offer the kind of enhanced Jupyter experience. Really about integration with your single sign-on capability, LDAP, PKI, Kerberos. People have enterprise single sign-on they've got to integrate with. And we've taken the Jupyter and Jupyter Hub capabilities, and we enhance those to integrate with people's enterprise stories.
Right. So like if they're logged in on their Windows machine on their Active Directory and...
Exactly. Active Directory interface.
You can have like a private Jupyter notebook running on the web that only they can get to. I see. That's
exactly right. So that's what the collaborative notebook capability. Then we've added a couple of little things. We're working right now. We've got a great project going on in conjunction with Bloomberg and the Jupyter team to actually the next generation of the Jupyter notebook. There's a phosphor project, and we're working closely with kind of how do we improve that. A lot of stuff. Again, we love to contribute to the open source. We love to make the foundations even better. And then typically we sell things that really help the enterprise and tie into their deployment conversation.
It seems to me like running a successful open source business is about having like different channels for different ways, different things you can offer to different people. There's a guy that
very insightful. Yes, indeed.
Yeah, thanks. A guy that blogs and podcasts a lot about sort of tech business stuff. And he has a really interesting saying that it's harder to go from 0 to 1 cent than 1 cent to $10. Do you feel like it's kind of that like get somebody to open up their pocketbook at all is like the big step, and then you kind of have this relationship?
Yes, agreed. It's a big jump to go from not paying you anything to paying you something.
Yeah, even if the something is super small, right?
Exactly. And when we first started the company, that's actually why we had these add-ons, and we've just switched our promotional model, like how we're shipping, what we're selling on the product side. So we're in the middle of that transition still a little bit with some customers where we used to sell these add-ons. And part of that, the reason we did that was precisely to just have a conversation about selling something with those who would engage in that direction. So because I knew we would be promoting open source, I knew we would be driving a lot of stuff for free, and I was excited about that, but I knew we also needed to have I'm going to sell you something conversation so we could segment the market appropriately.
Yeah.
And then kind of set expectations that this is what Continuum is. We do both. And so people can understand if they only want to engage with us and our free stuff, they can do that and understand that that we're not, it's not a bait and switch. It's not a, we're certainly trying to encourage adoption, and hopefully some of those might buy our stuff later. But if you've decided just to use the free stuff, you use the free stuff. Let's collaborate on open source. Let's collaborate in the community. Let's collaborate around how we move this thing forward together.
Yeah, absolutely. That's great. So, Travis, we're getting kind of short on our time here. Do you have any call to actions for the listeners out there?
Yeah, you bet. Absolutely. I would say definitely go and download Anaconda. If you haven't tried it, I think if you're a new user, absolutely download Anaconda. But if you're an old Python user, you might find that we've actually solved some things that you're having trouble with in terms of, and you might try it. It doesn't interfere with your Python installation. It's you can install it on your user account and kind of use it separately. A lot of people used to tell me they were afraid to install anything new because they would mess up their work. Anaconda doesn't mess anything up. It's just completely separate.
Yep, and you got a Python 2 and a Python 3 version, right?
We have Python 2, Python 3 version. And then, see if you want to sign up for an Anaconda Cloud account. It's a free account, and you can post packages there. And then if you're an academic, you can get access to our proprietary libraries through that Anaconda Cloud account as well. And, set up an Anaconda community somewhere, locally, and attend a PyData conference. There's a PyData conference in New York coming. Attend one, and if it's not one that's coming near you, there are 10 next year coming near you, then set up an Anaconda community and participate.
Yeah, that's excellent. Are you guys going to be at Pycon?
Yes. We go to Pycon. We will be there again, I'm quite sure. In Portland this year, right?
Yeah, excellent. That's my hometown. I already got my ticket, so it's going to be great.
Hey, all right, we'll see you there again.
Yeah, I hope so. Cool. And then 2 other questions I always ask my guests before I let you go. If you're going to go write some Python code, what editor do you open up?
So it's either VI or Sublime Text these days.
Okay. Yeah, they're both good. Good. And of all the PyPI packages out there in the world, 60,000+ of them. Do you have some favorites or maybe things that people don't know about that you're like, oh, I wish you knew about this. I should tell everyone.
Oh, so many. I will tell you about distributed. Distributed is one that we are working on. Matt Rocklin, who's many may know about because he's really cool and does a lot of cool stuff. Distributed is it's a way to do parallel computing in a modern Pythonic approach, and it's going to be the way Dask runs on multiple machines.
Okay.
So it's a separate library, and it'll be the foundation for how Dask. So there's 2, distributed and Dask. I think those are worth your attention, and a lot of people already know about them, but those who don't, they're worth looking at because they're going to basically give to Python a Spark equivalent.
Okay, that's awesome.
Kind of without Spark, for at least the medium scale, tens and 20s of nodes. All
right, Travis, it's been great. Thanks for being on the show. Really appreciate it.
I really appreciate it, Michael. Thank you so much, and good luck with future shows.
Yeah, thanks a lot. Bye-bye. This has been another episode of Talk Python to Me. Today's guest was Travis Oliphant, and this episode has been sponsored by Hired and DigitalOcean. Thank you guys for supporting the show. Hired wants to help you find your next big thing. Visit hired.com/talkpython-to-me to get 5 or more offers with salary and equity presented right up front and a special listener signing bonus of $4,000. DigitalOcean is amazing hosting blended with simplicity and crazy affordability. Create an account and within 60 seconds, you can have a Linux server with a 20 gig SSD at your command. Seriously, I do this all the time. And don't forget the discount code. It's TalkPython, all caps, no spaces. Did you know you can personally support the show as well? Just visit patreon.com/mkennedy and join over 100 listeners who contribute between $1 to $2 per episode. It makes a big difference, and I really appreciate it. You can find the links from today's show at talkpython.fm/episodes/show/34. And be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can find the iTunes and direct RSS feeds in the footer of the website. Our theme music is Developers, Developers, Developers by Corey Smith, who goes by Smix, and you can hear the entire song on talkpython.fm. This is your host, Michael Kennedy. Thank you so much for listening today. Smix, take us out of here.
Stating with my voice, there's no norm that I can fit within. Haven't been sleeping, I've been using lots of rest. I'll pass the mic back to who rocked it best.